Hello everyone. So another video, but this time on modulus functions. And what are modulus functions? Well, you may or may not know that the modulus is also known as the absolute value on your calculator. So if you typed in abs and then -3, that would give you 3, because that is the same as saying what's the magnitude of -3. You can treat -3 as like a vector. The number -3 is a vector along the number line, and if you're saying what's the magnitude of that vector, well, that's the length of that line. So the modulus function is the magnitude of a of any number or any vector quantity which you know has magnitude and direction. This builds us to, well, why is the modulus function useful? Well, think about it. If you had a velocity and a particle moving at velocities, let's say it moves like this. So what does this mean? It means that the particle has got speed in a positive direction here, and then it stops. So it goes here, starts to slow down until it stops, and then it starts to reverse, and then it stops, and then it speeds up again in the forward direction to here, and then starts to slow down until it stops, etc. If we are only interested in speed, however, it doesn't matter whether it's reversing or going forwards. The speed is always going to be a positive quantity, isn't it? So it's always going to be a magnitude of the velocity, and therefore you're always going to have positive y values. Also, anyone interested in electronics, that's why electricians will model stuff using the modulus function, because they're interested in magnitude of, amplitude, power, voltage, all this kind of stuff. Okay. What type of modulus functions are there then? Well, there are two. There is the y equals the f of x modded, so mod f of x, and there is the y equals f of mod x. You're going to see the difference between these two in a second. Just essentially, look, if you look at this, you're saying that y is always the magnitude of the function. So all y values will be positive. Whereas here, you're saying all the x values, whatever. So here you're saying that f of x and f of minus x will be the same, because when you magnitude them both, they're going to give the same value inside, because f of mod minus x is the same as f of mod x, which is f of x, right? So essentially what you're saying is that the negative values of x, so the negative values of x will give you the same y values as the positive values of x, if that makes sense. If you put in, if this is all your x section here, and this is all your minus x section here, then f of x will give you a certain value. F of minus x modded will be the same as f of x, so it will give you the same values as just x, you see? So if there's a y value here, the minus x will give you the same y value. Let's see that actually in practice then. So here we got y equals mod x. I'm going to take this graph. So y equals mod x. So let's start with f of x equals x. So let's start with the original. It looks to me that everything has been modded. So y equals mod x, doesn't it? So what we're going to do is we're going to draw the original in dotted lines. So this is y equals x. That's the original. Important to label that first. And let's think about it. So when x is 1, I get a corresponding y value of 1. When x is 2, I get a y value of 2. When x is -1, I get a value of -1, and -2, I get a value of -2. If I then go, right, bang, and mod everything, let's think about it. So if I have x equals 1 modded, that still gives me 1. So therefore, f of x modded is going to give me a positive value of y, right? Because y equals the mod of x, or f of x equals mod of x, let's say. Or y equals bang bang. Alright. So therefore, if I whack in 2, then I mod 2, I still get 2, and therefore I get a corresponding y value of 2. Whereas if I have minus 1, modulus of minus 1, so f of x equals the modulus of minus 1 at that point, right? Then therefore, I'm going to get minus 1 magnituded is 1. So minus 1 will give a corresponding value of 1. If I have x equals minus 2, so when x equals minus 2, my y equals modulus of minus 2, which is 2. So therefore I get a corresponding y value of 2. So can you see that what I'll end up with is this V-shape, this V-shaped graph. Because all the negative values of x, so when y equals mod of minus 1, I get 1. When y equals mod of minus 2, I get 2. When y equals mod of minus 3, I get 3. I get the same, all my negative y values have been made positive now. So this graph in itself was the original y equals x, because it's really important to label the branches. And this branch, you can see all the x values have been times by minus 1. So this is y equals minus x now. You can see that this graph is a negative linear graph here. So they're my two branches, really important to label it. Let's make that a bit more obvious with y equals number 2, 3x take 2. So I'm starting with f of x equals 3x take 2, draw my original. No, it crosses at minus 2. Where does it cross the x-axis? Well, that's when y is 0. So cross that over, that's 2 over 3. Draw the original dotted line. And now we know that what this means when y equals mod f of x, we're saying all y values become positive. So therefore, wherever this thing dips below the x-axis, this now flops up because all of our negative y's are being modded. And therefore it flips up to make this V shape again. So therefore this thing crosses at 2, not minus 2 anymore. Here was the original graph. So this is y equals 3x take 2. This one though, remember all the x values have been times, sorry, all the y values have been times by minus 1. So therefore we get y equals minus 3x plus 2. All the y values become positive, all the y values have been times by minus 1 when they dip below the x-axis. Okay, let's try that again, but with a quadratic this time. So I got y equals 3x take 10. Here I start off with my original. F of x is x squared minus 3x take 10, so I can draw it. If I factorize that, I now know where it crosses the x-axis, so that's at 5 and 2. There we go. Oh, sorry, that should be a plus. So that's 5 and minus 2. I know it crosses the y-axis, that's at minus 10. The turning point is going to be in the middle of these two, so I don't know, it's about there. So I can sketch that like that. Really important to get the turning point in the right place. And like before, all y values have been times by minus 1 when they fall below the x-axis, i.e. all y values become positive. So this was positive already, no change. This though, this flips up. And where it crossed at minus 10, now it crosses at 10. And still crosses at minus 2 and 5. Label our branches again. This one was part of the original, so no change. This was part of the original, so no change. This one though, all the y values are times by minus 1, so I will times all the y values by minus 1 in my equation. And there we go. Done. Whereas number 4, you have a different scenario. Number 4, so 1, 2, 3. Number 4, you got a different scenario because this is in the form of y equals f of mod x. So let's see what that means. So we do the same again. f of x, draw the original. There's the original. We drew it a minute ago. It looked like -2 and 5, dotted line, and that was -10. Okay, this time let's investigate some numbers. So we have y equals mod x squared minus 3 mod x minus 10 this time, don't we? So if I start investigating numbers, because now I'm modding everything in here, yeah? Just like over here, I modded all the outside, and that mirrored that one this time. This time I'm going to just mod the inside of the brackets, and whatever's in there comes out in here, remember, right? So if it was f of lemons, I get lemon squared minus 3 lemons minus 10. So what repercussions does that have? Well, let's test it. So when x equals 2, I get y equals mod of 2 squared minus 3, 2, minus 10. So that's 4, take 6, takes 10, so that's minus 12. So here, x equals 2, I get minus 12. If I whack in x equals minus 2 though, I get y equals minus 2 modded squared, minus 3, minus 2, minus 10. Mod of minus 2 is 2, squared is 4. Take away, mod of minus 2 is 2, so that's take away 12. Take away 6. And minus 10, so I still get minus 12 again, do you see? So at minus 2, instead of getting y is 0, I actually get minus 12 again. And I could keep going. If I went for x equals 1, I would get, in my original, y equals mod 1 is 1, minus 3 is minus 2, minus 12 is, minus 10, let's do that again. So 1 squared, minus 3, 1, minus 10. So 1 squared is 1, minus 3 is minus 2, minus 10 is minus 12. And that makes sense because 1 must be on the other side of that turning point, so there's minus 12. So actually my original is like that. Okay, so if I put in minus 1 again, so here I'm putting minus 1, I still get minus 12, don't I? Because mod of minus 1 is 1. So I get another minus 12. So look, if I start joining the stuff together, can you see I've got a carbon copy of the right-hand side? A carbon copy. So we're saying that when y equals mod f of x, no negative y values, or all values of y flipped up. When y equals f of mod x, all right-hand side is copied onto left-hand side. You can see there's a mirror image on the from the y-axis here. Let's label our graph branches then. This one hasn't changed. This was our original. This was x squared take 3x take 10. No problem there. This one though was all the negative x values. So if I put in negative x into here, so y equals minus mod x squared minus 3, sorry, not mod. Ugh. This one here was all my positive x values in here. This one here, though, is all my negative x values in there. So if I've got y equals, instead of timesing everything by minus 1, I've only got my x's are times by minus 1. So you've got to be pretty careful there. Minus x all squared is x squared. Minus 3 times minus x is plus 3x and minus 10. So the only change is plus 3x instead of the minus 3x. Let's reiterate that with another example. Just make that dead clear. So this time number 5, I've got y equals 4 mod x take mod x cubed. So take the original, f of x is 4x take x cubed. Factorize it so I can start drawing it. So that's a difference of 2 squares right there. Where's it crossed then? So it crossed at 0, 2, and minus 2. It's a negative quadratic cubic, which means it starts high, ends low. Dotted line. There we go. But what I'm doing is I'm modding everything in there. So mod, 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 mod. Right? So all the x's are now modded here. And therefore, we get a carbon copy of the right-hand side. So here's the right-hand side, and now it's duplicated on the left-hand side because of those corresponding numbers. Again, just a quick check. If I try x equals 1, I get y equals 4, mod 1 minus 1 cubed. That gives me 4 minus 1 is 3. So at 1, that gives us 3. If I whack in x is minus 1, y equals 4, mod minus 1 minus 1 cubed. Mod minus 1 is 1, so that's 4. Take away mod minus 1 is 1 cubed. So that's still 3 again. There we go. You can really see now how this thing is working, I hope. Labeling the branches though. Y equals 4x take x cubed. This was the original. This is the new one. All negative x values are included in this branch. So this is your y equals 4. Wherever you see an x, minus x all cubed. So this is minus 4x, minus x all cubed is still minus x cubed, so that's plus x cubed. Be very careful labeling these branches. Whereas, if I wanted to do y equals mod 4 minus x cubed, 4x minus x cubed, sorry, that would be all the y values flipping up. So 2, 0, minus 2. There's your original here. Starts high and low. And then we would take all your y values as positives. Making sure the shape's the same. Do you see? Sorry, let me... what's going on? Let me redo that. Original 2, minus 2, 0. Starts high, ends low. It's a carbon copy of the right-hand side for when we have f of mod x, but when we've got mod f of x, all of your negative y values become positive. So we were right, and just making sure that we understand that rule. Fantastic. And again, labeling our branches in that situation. This was part of the original graph of 4x minus x cubed. This bit was not part of the original graph, so everything is times by minus 1. This bit was part of the original graph, and this part wasn't, so everything times by minus 1. And we're done. And then that's how you would sketch the graphs, and then it's a case of solving using those graphs.